Hello everyone. So in this video we can look at another important thing with regard to quadratic equations. So this is very important because it has come up in past papers since 2011 until 2021. Maybe it has come up before that as well. So this is very important to know, and this is an easy one. So two quadratics with one root in common. So in this case, we have two quadratic equations, and what is the criteria? What is the condition that has to be satisfied such that both quadratic equations have one root in common? So in general, quadratic equations have two roots in general. So if you have two quadratic equations here and here, two quadratic equations, that means each quadratic equation has in general two roots. So altogether there will be four roots. But in some cases there will be one common root. One common root for both quadratic equation, right? So we're gonna look into the condition that needs to be satisfied for a common root. So before we get into that, let's look at an example and see what is meant by a common root. Right, so let's look at this example here. This is a simple one. So we have two quadratic equations, and so since we are focusing on two quadratic equations with one root in common, which means we're going to have to find the root. We're going to have to find the roots and make sure and verify that there will be one common root, right? So how do you solve this one? This can be factorized easily. 2 equals 0, that leaves us with x equal minus 1 or x equal minus 2, right? So you can see that the solutions to this quadratic equation, by that I mean the roots of this quadratic equation is either x equal minus 1 or x equal minus 2. So what about this one? This can also be factorized. X plus 2 into x plus 3. So notice here that I took two quadratic equations that can be factorized, so I can get the answers to this. So the object of this simple example is not to show you how to get the solutions to quadratic equations. It is to show you what is meant by having a common root, right? So that's why I took a simple example there. So in this case we have x equal minus 2 or x equal minus 3. So notice here that this quadratic equation, in general a quadratic equation has two roots, right? Two roots. These are the two roots, and this quadratic equation has two roots. In general they have two roots. If we have coincident roots, that means there will be only one root there. So notice here that x equal minus 1 or x equal minus 2. X equal minus 2 or x equal minus 2. What is the common root? Common root is x equal minus 2. So x equal 2 is the common root for both quadratics, right? So this is the general way. It's not the general way. This is specific to this problem, but we will look into the most general case and how to obtain the common root, right, for two quadratic equations given. Right, so before we get into a more general case, let's take a look at a note here. So the note being, this is very important, especially when it comes to questions, to know what roots actually means. If alpha and beta are roots of ax squared plus bx plus c equals 0, so what can we do with that, right? So we saw in earlier videos that let me write this down. So in previous videos we saw that if alpha and beta are roots of ax squared plus bx plus c equals 0, we saw that we can get these relationships between the roots and the coefficient of the quadratic equation. So alpha plus beta in this case minus b over a, and alpha into beta in this case c over a. This is what we saw. but we don't need this one. I just wanted to refresh you on this. So what does it mean if alpha and beta are roots of ax squared plus bx plus c equals 0? So what is the intuition behind this? It means that if you replace x with alpha, this part will become 0. Suppose this is a quadratic function, not the equation. If this is a quadratic function and this is called the quadratic equation, so here we determine x values for which this expression is equal to 0. So having roots actually means when you substitute x equal alpha, a alpha squared plus b alpha plus c will be equal to 0. It will be equal to 0. Right, this is equation 1. So we can have two equations based on this one. If x is equal to beta, then replace x with beta, a beta squared plus b beta plus c equals 0. This is the second equation. So this is what is meant by having two roots. If alpha and beta are two roots of the quadratic equation, we should be able to write these two equations, this relationship. Okay. For example, so x squared plus 3x plus 2 equals 0. We found that the roots being x equal minus 1 and x equal minus 2. These were the roots, right, of this quadratic equation. So what does that mean? Let's substitute x equal minus 1 and check if this is true. When you substitute x equal minus 1, let's check if this equation is true. So we can check the left hand side and make sure that the left hand side is equal to 0. Let's check. So LHS, left hand side, x replaced by minus 1 square plus 3 into minus 1 plus 2. So what is that equal to? This is 1, this is minus 3, this is 2, 1 plus 2 is 3, 3 minus 3, this is equal to 0. RHS. So we showed that when you substitute this root to this quadratic equation, this is actually true. Next one is x equal minus 2, LHS. What do you get? X equal minus 2 squared plus 3 minus 2 plus 2 equals 0. This becomes 4, this becomes minus 6, and this is plus 2. Sorry. So what is this? 4 plus 2 is 6, 6 minus 6 is again 0. This is also equal to RHS. So we showed that roots means, when you have roots and when you substitute x by these roots, by the corresponding roots, this equation will be true, will be satisfied. That is what is meant by roots. So when you have roots, you can do a lot of things with them, like we did in the previous lectures. And this is what it really means, right? So we can use this relationship whenever it is possible. Okay. Now we are at a point that we can make a general approach to determining the common root for two quadratic equation. Okay, let's check that one. Right. So suppose we have two quadratic equations with different coefficients, provided that these quadratic equations are not equal to each other, right? Or they are not a multiple of integer multiple of one of each other, right? Have common root. Have one root in common, which is let us call it alpha, right? Let us set that equal to alpha. So what does that mean? That means ax squared plus bx plus c equals 0. If you take this quadratic equation, it has two roots in general. One is in common, and we state that the common root is alpha, so we put alpha there. And another one, let's call it beta, right? Alpha and beta would be the roots of this quadratic equation. And the other one, px squared plus qx plus d equals 0, it also has two roots in general, and we say that we stated that one root will be in common to both, and that is alpha. So we should have alpha to be one root and maybe another one called gamma. So you can see that alpha is the common root to both of these quadratic equations. Okay, so we're going to build up on this one. So if alpha is common root, then we can use this one. So we can have two equations here. I can substitute x by alpha. So when x is equal to alpha, I can get a alpha squared plus b alpha plus c equals 0. This is equation 1. This is equation 1. The other equation, this one. So I can take p alpha squared plus q alpha plus d equals 0. This is the second equation. So we can form two equations based on this data given. So what I want, if I want to find the common root being alpha, I have two quadratic equations, and alpha is in 4 places. Alpha is on 4 places. Here it is like, alpha is in alpha as in alpha, and here alpha as in alpha square, right? So in both places we have alpha. It's actually one unknown, but we have two equations there, right? So we are not going to resort to we can use actually one of them to find alpha. In that case, we will get alpha in terms of a, b and c. If we use this quadratic equation to obtain alpha, we will get alpha in terms of p, q and d. But since alpha is common to both quadratic equations, we should make use of the fact that both quadratic equations are involved in this. So we have to use both coefficients. Coefficients in both quadratic equations. That's what we have to use here. So what I'm going to do, I'm going to use these two quadratic equations to figure out what alpha is. So we can do this in two ways, right? To find alpha, we can do this. To find common root alpha, we can use two methods here. So the first method is that we can solve this simultaneously. What we can do is we can get rid of alpha squared terms. We can get rid of alpha squared terms by solving this simultaneously. That is the first method. Or we can get rid of alpha terms. We can get rid of alpha term and get alpha squared. What alpha squared actually means. So both come in handy based on the question. So we'll look into such questions in the classroom. But right, so I'm gonna do both methods, because when we move on to the next part, where we find the condition that needs to be satisfied such that two quadratic equations have one root in common, these two solutions, they're actually a single solution. So these two representations, that what we're going to do, will come in handy. So this is what I'm going to do, right? So to get rid of alpha squared, what I'm going to do, I can multiply 1 by p, first equation by p, then minus second equation by a. If I multiply first equation by p, this becomes pa alpha squared. Second equation by a, this becomes ap alpha squared. Then I can deduct these two. In that case, I get rid of these two, so I get bp minus qa. So I factored out an alpha from this directly. That is equal to, try this by yourself, this becomes PC minus DA, but this part should be on the right other side, so I'm going to write DA minus CP. So I wrote this directly. So in this case, alpha equals DA minus CP divided by BP minus QA. Right, BP minus QA. The next method, get rid of alpha. To get rid of alpha terms here, we have B alpha, we have Q alpha here. So I'm gonna multiply this by Q and this by B. So first one by Q minus second one by B. That gives us, right. So this part will be removed. So we have AQ minus PB alpha squared, because alpha squared can be factored out, so I did that directly. Then here we have QC minus DB, but I have to take them onto the other side, so that becomes DB minus QC. So now alpha squared in this case is BD or DB minus QC divided by AQ minus PB. Right. So we have two solutions there based on the coefficient. So based on the method we use, we get two solutions, but actually they both have to be equal to each other, because here we find alpha and here we find alpha squared, which means this part squared must be equal to this. So we're going to take the relationship between we're going to get the relationship between the coefficients. That means the condition that has to be satisfied by equating the square of this one to this. That way we can get rid of alpha from these two and get the relationship between the coefficient of the quadratic equations. Right. So this is alpha. So you can use either one of these. So especially we use this one, that if we use alpha, if you use this formula, this relationship to get alpha, so we can have to take the square root. When you take the square root, you get plus or minus. So two answers. So to circumvent that, we use this one most of the time. Okay. So this is the common root. Alpha is the common. So we saw the techniques. There are two techniques available to get the common root. Okay? To get the root in common to both quadratic equation. Right. So let's check. The next part, let's check what is the condition that has to be met. Right. So now we're going to find the condition to have one root in common. That means what must be satisfied, right, with regard to these quadratic equations such that they both have one root in common. Make හැම වෙලාවෙම වෙන්නේ නැහැ. හැම equations එකකටම හරියන්නේ නැහැ. එහෙනම් මොකක් හරි relationship එකක් සම්බන්ධතාවයක් තියෙන්න ඕනේ මේ quadratic equations දෙක අතර, between the quadratic equations මේ common root එකක් එන විදිහට. හැම වෙලාවෙම එන්නේ නැති හින්දා. ඒතර common root එකක් ඇති වෙන්න නම් මොනවද වෙන්න ඕනේ? ඔන්න ඕක තමයි දැන් අපි බලන්නේ. මොනවද වෙන්න ඕනේ? quadratic equation එකේ වෙනස් වෙන්නේ මොනවාද? Coefficients. These coefficients are different, right? So we can change these coefficients any way we want, which means based on these coefficients, the roots will be changed, right? The coefficients වෙනස් කරද්දී roots අනිවාර්යෙන් වෙනස් වෙනවා. ඒතර මේ coefficients වෙනස් කරගෙන යද්දී එක විදිහට කරගෙන යද්දී එක වෙලාවකට මේ roots වලදී එක root එකක්, roots දෙක තියෙනවනේ, එකක් common වෙන අවස්ථාවක් තියෙනවා. ඒ මොන අවස්ථාවේද? ඒ වෙලාවේදී ABC and PQD මොන වගේ රිලේෂන්ෂිප් එකක්ද තියෙන්න ඕනේ. right? ඒතර අපිට මේක trial and error method වලින් කර ඉන්න බෑ. Logically මේක අපි derive කරමු. So we took these two relationships here. One for alpha and one for alpha squared. which means this one squared must be equal to this. So here if we take alpha squared, in this case this becomes dA minus Cp over Bp minus Qa whole thing squared. This must be equal to this one. So Bd minus Qc Aq minus Bp. So now I can see here that we have Bp minus Qa, this is Aq minus Bp. So I can write it like that, dA minus Cp squared. This one is Bp minus Qa squared, Bd minus Qc Aq minus Bp. Aq minus Bp. Right. So you can see here that this is Bp minus Qa, this is Aq minus Bp. I can factor out a negative sign out of this one. Even if I do it, since this is a square, nothing will happen, right? So I can get rid of one of these. I can write then dA minus Cp square must be equal to Bd minus Qc into Bp minus Qa. Bp minus Qa. This is the condition that has to be met to have one root in common. Right. So please don't memorize this one. Do not memorize this one. Okay. Just get an idea about the technique that we use and how it has been applied to this problem until we get to this point. So do not memorize. Do not memorize this. Right. So this is how you do it. So when it comes to questions, they might ask you to show a certain condition that has to be satisfied in order for two given quadratic equations to have one root in common. So in that case, this is the way you follow. First, you write down the two equations with one root in common, a alpha squared plus b alpha plus c, then p alpha squared plus q alpha plus d equals 0. Then get rid of alpha squared terms first and get this answer, then get rid of alpha terms and obtain this relationship. Right. So this is actually the common root. Okay. Then after that, if you want to find the condition, right? So the relationship between the coefficient of the quadratic equations, what you do is you just equate these two, square this one and equate this, and you will get the condition. So this is the technique. Okay. So then there's one more part, and we'll get into that. So this would come up in the questions, the next part, more often it has come up. So we will look into that one as well. Now here's the thing. So each quadratic equation will have two roots in general. This one two roots, this one two roots. You can see alpha, beta, alpha and gamma. Why alpha? Because both of them has one root in common, right? So that was our assumption. So what about beta and gamma? Can't we find beta and gamma separately? Yes, there's a way to find beta and gamma. So we'll see how to do that in the next part. Right. So how do you find the other two roots? So we how to find how to get the common root when the two quadratic equations are given. And we have two other roots remaining, beta and gamma. Is there a way to get this? Yes. So we can use the relationship we obtained in previous videos. Here, when two roots are given based on this quadratic equation, you can write alpha plus beta equal minus coefficient of x divided by coefficient of x squared, and alpha into beta constant divided by coefficient of x squared. Again, similarly, alpha plus gamma here, two roots, coefficient of x divided by coefficient of x squared, alpha into gamma, constant d divided by coefficient of x squared. Now here's what we're going to do. We're going to use these two relationships because we already found alpha here. If I substitute alpha, the value in this equation, I can get beta. If I substitute alpha in this relationship, I can get gamma. So I can use this relationship, alpha beta equals C over A. Based on this, I can find beta equal C over cross multiplication A into 1 over alpha. So I can just put A alpha if you like. If you like, you can put A alpha. The other relationship, alpha gamma equal D over P. So gamma would be D over P. I'm going to write this separately, and 1 over alpha, the reciprocal. I wrote the reciprocal. So it's clear to you. That's why. Now I can just take the reciprocal of this. So in this case, beta would be therefore C over A. What is the reciprocal? BP minus QA. BP minus QA divided by DA minus CP. Similarly, gamma would be D over P, BP minus QA divided by DA minus CP. Right. So this is how you obtain the other two roots. Right. So in questions, they might not ask you to find beta and gamma, the other roots. They might ask you to find directly what is a quadratic equation whose roots are the other roots of these two quadratic equations. So in that case, you still have to find these two, alpha and beta. Then we can find the quadratic equation corresponding to these two as their roots. Right. So that's a very simple one. We have done. We learned the theory part that is necessary to build up the quadratic equation based on this one. So let's check that one. Right. So to find the quadratic equation whose roots are beta and gamma, you know that given two roots, we can just write the quadratic equation like this: x squared minus addition of the roots gamma plus beta or beta plus gamma times x plus the multiplication beta into gamma equals 0. So based on this, we can write x squared minus beta is that C over A alpha, then D over P alpha x plus beta is C over A alpha into D over P alpha equals 0. Right, so we can take the common denominator here. When you take the common denominator, you get A alpha, A times P times alpha, AP alpha, CP plus DA. So I can substitute alpha, if necessary, substitute alpha, please. I'm not going to do that here, x. Then CD over PA alpha square equals 0. This is the quadratic equation whose roots are the other roots of these two quadratic equation given. So it's very easy, right? So let's look into some examples now. I'm going to do 3 examples, and it will be clear to you. I will do more examples in the class.